Okay, my dear. So today we are going to start with the electrolysis in detail. ठीक है जी, इलेक्ट्रोफोरेसिस को हम लोग जो है वो डिटेल में करने जा रहे हैं गाइस. अच्छा जी, व्हाट इज द इलेक्ट्रोफोरेसिस? मैंने आपको कल बताई थी कि टू टाइप्स की होती है. द फर्स्ट वन दैट इज कॉल्ड एज द पेपर इलेक्ट्रोफोरेसिस, and the second one that is called as the gel electrophoresis. Okay, so you got the two types of the electrophoresis. The first one that is the paper electrophoresis, and the second one that is the gel electrophoresis. Uh, First of all, we are going to start with the paper electrophoresis. In the paper electrophoresis, my dear, what would happen? Basically, take a slide of glass or plastic. Okay, so this is the slide made up of glass or plastic. So let's suppose this is the glass. So glass slide you have taken. Now the second thing, my dear, you have to take a paper. Okay, so that paper is a special chromatography type of the paper. Okay, it's just like a filter paper. Okay, so you cut the filter paper of that size. Okay, dip it in some buffer solution of pH 8. You can take any of the pH acidic or pH neutral, whatever the pH you want to take. Take. So normally, whatever the pH we consider, that is the pH 8. Okay. So put a piece of paper. Okay. So this is the paper dipped in buffer solution of pH 8. Okay, so pH 8, that is actually the basic pH. Okay, it's the basic pH. Now the next step, you have to take the crocodile pins. The crocodile pins you have seen, they are going to clip the different papers. Okay, if you got a bundle of papers, you should clip them with the help of the crocodile pins. Okay, so these are the crocodile pins. Okay, and this is the crocodile pin as well. Okay, now join this crocodile pin with a high voltage current. Okay, this is the positive, this is the negative terminal. Okay, so this is the high voltage current. High voltage current. Okay. Now the next step, my dear, what should you do? You should take a dropper. Let's suppose I just want to know that which type of amino acids are present in my skin. Okay, so what I do, I take a small piece from my skin. Okay, put it into the acid. When you put it into the acid, the protein of that acid that will dissociate into amino acids. Okay, it will hydrolyze into amino acid. So protein will break down into the smaller units which are called as the amino acids. Okay, so you got the mixture of different amino acids. Okay, now by dropper, shift the amino acid in the center. Okay, so this is the sample you applied. This is the sample, and this sample containing a pair that is the mixture of amino acids. Okay. So you know that amino acids, I told you yesterday, amino acids, they are of different kinds due to the presence of the different R group. Okay. I told you earlier that this is a general amino acid in which this R group, the change of R group will change the amino acid. Okay, so you got different R groups attached up here, and normally whatever the R group you need, they are openly provided in the data booklet, or they are going to provide you in the question. You don't need to memorize it. Okay, R group. These three things you should know. With carbon, we got carboxylic acid, we got amine, we got hydrogen. On the fourth side, the R group that is normally given in the data booklet or in the question. Okay. Now, this is the mixture of amino acid. You have applied the mixture of amino acid up here. At that pH, okay. So amino acid got the two groups, carboxylic acid and amine group. And this R group may contain carboxylic acid or amine group as well in it. Okay. So at that pH, some of the amino acid they would be neutral. Okay. So some of the amino acids they would be neutral. Some of the amino acid they would become positively charged, and some of the amino acid they would become negatively charged. Okay. At that particular pH, the different amino acids they will form different ions. Okay. Some of them they would be zwitterine, some would be negative, and some would be positive. So this is the negative terminal. This is the positive terminal. The negative ions, the negative amino acids, they will move towards the positive thing, okay, and they will form different spores up here. The rate of movement of these ions it depends on three factors. The first factor, what is the MR of that particular amino acid? You know that greater the MR, what would happen? The rate of movement that would be slow. Okay. If the MR is low, the movement that would be fast. Okay. So if an amino acid is heavier, having more MR, so it will move slower. Okay. The second thing on which this rate of movement that depends, that is the charge on amino acids. Some amino acids they are having positive charge, so they will move. They are attracted. Sorry, they are having negative two charge, so they will move faster. Okay, so amino acids which are having negative one charge, so they will move slower. Okay, so in this way, my dear, the rate of movement that would happen. Okay, so then these are the positive amino acids. They will move toward the negative thing, and the amino acids which are zwitterine forms, zwitterine mean they are not positive. They are negative. They are not positive and negative. They are having negative one and positive one on both sides. Okay. So negative one and positive one, they would form neutral thing. Okay. So it would remain in the middle. So middle में okay, they won't move. Okay, so just write it down. The rate of movement of ions depend on three factors. Number one, the charge on amino acid. The second thing, the MR of amino acid. The third thing, the current applied. If you apply more current, the current is more, the rate of movement that is faster. Okay, did you get it? Okay, guys. Now write down the details of these things. The first thing, put a mixture of amino acids in the center of paper dipped in buffer solution of pH 8. Okay. At pH 8, some amino acids would be in deuterine form, mean neutral. Some are positive ions and some are negative ions. Okay. The positive ions are attracted towards the negative terminal, whereas the negative ions are attracted towards positive terminal. The next point, the sweeter ion would remain at the same position where the sample had been dropped. Are different amino acids are separated amino acids would form colorless spots and can be visualized by our locating agent ninhydrin. Ninhydrin make the amino acids to be purple. And here the distance of amino acid from the center point and compare it with the standard amino acids results with same conditions of pH and current will result in the identification of amino acids. ठीक है बच्चों, आप लोगों ने क्या करना है? फर्स्ट ऑफ ऑल अमाइनो एसिड का जो मिक्सचर है वो सेंटर में लगा देना है एक पेपर के ऊपर, एंड दैट पेपर हैज बीन डिप्ड into a buffer solution of pH 8. Okay, at that particular pH, different amino acids they would become positive, some would be negative, some would be neutral. Okay, and they would start moving towards positive or negative terminal, or some of them they would remain in the center. Okay, the rate of movement of ions that depend on MR. I told you all these things. Okay, now what would happen? Those amino acids, when they travel, they are not visible. They will form the colorless spores. So you can visualize them by spraying a locating agent ninhydrin on them. Ninhydrin make them purple and the spores they become visible. Okay, now measure the distance of that spore from the central point where you apply the sample. Okay, and note down that distance. Then compare it. You have done this whole process with some standard amino acids. Okay, there are 22 amino acids, so you have done the same experiment. You know that this amino acid is alanine, so you put it on the paper of pH 8 buffer solution and apply the same current and see how much distance it traveled. So you note it down firstly before starting this experiment. Okay, then the mixture, whatever the distance they travel, so you compare that distance with the standard amino acids you have done before. Okay, and whatever the distance you find out, you compare it with the standard, so it will help you in the identification of that particular amino acid. Okay, so this is, my dear, the paper electrophoresis. Okay, so this is the paper electrophoresis. Okay, so we will do the gel electrophoresis inshallah tomorrow. So tomorrow we will finish this electrophoresis topic. Okay.